Piecewise linear models. So problem 1, the cost of printing invitations depend on the number of invitations printed as shown in the piecewise linear model. Asks us to find the gradient. So our gradient, once again, is equal to what we call slope. So we want to find the slope for AB. We're going to take these two coordinates, 0, 0, and 100, 50. And we go ahead and use our slope formula. X2, Y2. Here is your formula. So we'll have 50 minus 0 over 100 minus 0. So you have 50 over 100, which reduces to 1/2. So AB is equal to 1/2. And then BC, we'd be using B and C as our coordinates to find its gradient. So 100, 50, and then 200, 80. So our x1, y1, x2, y2. So we'd have 80 minus 50 over 200 minus 100. So that is 30 over 100, which is 3 over 10, which is 0.3. And so our slope, our gradient for BC is 0.3. Part B is asking us to find the cost of 16 printed invitations. So each mark down here on the x-axis is going by 20. So if we're at 60 number of invitations, the cost is $30. Then it says how many invitations can be printed for $74. I think the best way is to make an equation. I'm going to do an equation in point slope form. So y minus y1 equals m times x minus x1. And I'm going to use point B for my x1 and y1. So 100, 50, x1, y1. So I have y minus 50. My m, since I'm looking at this section, because the cost is $74, so it's somewhere around here. I'll be using the slope for BC, which is 0.3. X minus my x1, which is 100. They did tell us what the y is. It's the $74. So now it means I'm going to replace this y with 74 bucks. All right, going to start calculating this out. So 74 minus 50 is 24. And then we have 0.3x when we distribute. Then 0.3 times 100 is -30. We would add the 30 over to the 24, making 54 equals 0.3x. Divide both sides by 0.3 gets you 180. So that's 180 invitations. Okay, so this one, the cost of sending a parcel overseas depends on the weight of the parcel. The first one would like us to make a graph of this. So I'm going to make my axis. This is weight. And this is in kilograms. The vertical axis is the cost in dollars. My x-axis is going to go by ones because it's in kilograms. And looking, we're at 13, 23, 32, 40, and so on. So I'm going to go by tens. 10, 20, 30, 40, 50. So looking at our table, it says up to 500 grams for $13. So at $13. 500 grams would be halfway between 0 grams and 1 kilogram. And then it says over 500 grams up to 1 kilogram is $23. So I go right up to about 23 is going to be, I make an open circle, and I go ahead and go all the way to 1 gram and close my circle. Then I'm going to do 1 gram to 2 grams is $32. So I go up to roughly where $32 is. I go all the way to 2 grams, close my circle. And then over 2 grams up to 3 grams is $40. So I go up to 40 bucks, open circle, all the way to 3 grams, close my circle. And then here it can be kind of confusing to read. It says extra kilograms or part thereof is $5. So it's trying to tell you that every gram you increase is a $5 increase. So the rest of your step piecewise function would look like this. Part B is asking us to find out the cost given the different weights. So this is essentially, you could use the table over here on the right, or you could use your graph. It doesn't really matter. So 750 grams, so that's going to be over 500 grams, but less than 1 kilogram, so that's $23. 1.6 grams, so that's between 1 and 2, so that'll be $32. And then 3.4 grams, so 3.4 is right here, that's at $45. And there you go. All right, our last problem, this one's a bit of a tricky problem. It's meant to be kind of a goofy one. I just kind of wanted to expose you to how to do it. So it's going to ask us to make a graph. This table shows income tax related in the UK. So we have income, and then we have the taxes that are paid. So I'm going to go ahead and make my axes. So here we have our income, and then up here we have tax paid. So looking kind of at our numbers over here on the X, I think I'm going to go up to 200,000, and I'm going to go by 50,000s. And hopefully I spent thousands right. All right, and then the Y column, I'm going to go by 10,000s. Once again, this is in thousands. All right, so looking at our first row, it's letting us know that 11,850 pounds is paid nil, which means 0. So it will be like, we'll say about here. Okay, so that is that point. And now we're going to go to the next row. And the calculation behind it is, since now we're looking everything past this coordinate to 46,350 pounds. That's our new X value. Now our Y value is taking the difference between these two and timesing it by 0.2. Now the 20 cents for each cash of each pound is essentially what you're doing. So once we know the difference, so we have 46,350 minus 11,851 is going to be 46,350. Sorry, it should be 11,850 because we're taking from the last place we left off. That's going to give us 3 $1.4499. And we're going to times that by the 20 cents because each of these dollars is going to be worth 20 cents. So we would get 6900. So our new coordinate is going to be 46350, 6900. So that's going to be about here. And we'll do that in green. Now you'll notice that number we got shows up right here. So to help us in our next one, we actually don't need to do this calculation because it's going to show up right here. So our next X value is 150,000 and its Y value is right there because they already did the calculation for us. We just had to realize how they got the calculation to know where to pull our number from the Y column. So we'll go to 150 and we're going to 48,000. So probably around here. And that is our next piece of the piecewise. We do need to figure out the next part to go beyond, because it's asking us to go beyond this. So to do that, we are going to take our, since my table goes up, my x-axis goes out to 200,000, I'm going to go 200,000 minus the 150,000, the one before it. It's going to give me 50,000. And I'm going to times it by 0.45. So I'm going to get 22500. And now that I have that, I will add the 48360 to it. So you have 7860. So you're looking at about here. And so it curves up a bit more, going on to infinity. And so this is just kind of a goofy problem. I just kind of want you to see what something like this would look like. I'm not going to put it on an exam or anything like that, but I just wanted to expose you to it. And that's all I want to go over. Now there's 3 problems on eCampus that are a classwork assignment that can practice probably problems like number 1 and 2.